These are the examples for Algebra 1B, Credit 3, Lesson 19.1. Lesson 19.1, we're going to be graphing parabolas, more specifically graphing, or we could also say graphing quadratic equations. And what you're going to be given is the parent function f of x. And notice here we have f of x graphed. It's f of x is x squared. And when we say a parent function, that means there's no transformations, no stretching, no movement of the graph, no compressing. And so we have this parabola graphed here. And what we're going to do is we're in lesson 19.1 is graph three other quadratic equations. And we know these are quadratic equations because we have an x squared, or we more specifically, the highest power of x, the only power of x here is 2. So we're going to graph these other equations and see how they relate to the parent function x squared. All right, so we're going to put our work in here, but we're going to have to erase it because we don't have a lot of space for the work. So let's start with our first one. So again, our parent function, and let's even note that here, that's the parent function. X is x, f of x equals x squared. So we're going to graph an example for number 1, 2x squared. And we have our table here, and we're just going to substitute each of these values in for x. So our first value is -2, so we have 2 times -2 squared. Remember, squaring a number, well, let's back up a step, actually. So remember, order of operations tells us that we're going to be doing our exponent, squaring the -2, the number, before we multiply. So let's go ahead and do that. -2 squared, -2 times -2. So recall that squaring a number means multiply by itself. So a negative times a negative is a positive, and 2 times 2 is 4. So we have 2 times 4, which is just 8. All right, next we have -1. And we're going to go through this a little bit, maybe more quickly. Again, pause the video if you want to take some more time to review what we're doing up here. Won't go too quick, but we want to make sure we get through this in somewhat of a timely manner. So again, pause, rewind the video as needed. All right, next we have 2 times -1 squared. -1 times -1 is a positive 1. And then 2 times 1 is, of course, 2. Next we have 0. So 0 squared is, of course, 0 squared. We can square 0, but that's just 0 times 0, which is 0. And then 2 times 0 is 0. Next, we have +1. And I think we got the idea of squaring a number. Maybe, well, actually, let's finish the rest of these and we'll do the other ones verbally. Next, we have +1. So 1 squared means 1 times 1, which is 1. And you don't want to go too fast when you're doing these, because sometimes you make the mistake of course, we all know what 1 times 1 is and what 1 plus 1 is. But then if you go too fast, then sometimes you get mixed up. Or not mixed up, but you're going too fast, you put the wrong answer. So 1 squared means 1 times 1, which is 1. 2 times 1 is 2. Finally, 2 times +2 squared. So 2 squared means 2 times 2, which is 4, and then 2 times 4 is 8. So now we have our table completed, and each of these columns in our table is an ordered pair. So first of all, we have -2 and 8, and we'll go over to the graph. And so -2 would be 2 to the left and up to 8. Now, the ones you're going to do, these numbers are going to be helpful. I'll just leave it at that. But here we're going to have to kind of estimate where 8 is. So 8 is going to be between 9 and 6, a little closer to 9. And so there would be the point -2 and 8, about right there. Next, -1 and 2 would be 1 to the left and 2 up, so just below the 3 line here. 0, 0, of course, is the origin. 1 and 2 is 1 to the right, and then 2 up, so just below the 3. So between 0 and 3, but closer to 3. And 2 and 8 would be 2 to the right, and then once again, just below 9. So let's go ahead and graph that, or connect the dots. And that is our g of x function.
And notice that g of x is thinner, or we could say narrower. Sometimes we'd say a vertical stretch by a factor of 2, but we notice that the graph is more narrow than the parent function x squared. All the points have kind of been raised up, which makes the graph narrower. All right, now let's take a look at the next one, our example for problem number 2. We have negative 2x squared. So starting with our first value of x, negative 2. Negative 2 times negative 2 is kind of the same numbers we have here, so that should be pretty easy to work with. Again, recall that negative 2 times negative 2 is positive 4. Negative 2 times 4, though, negative times a positive is a negative, and 2 times 4 is 8, so that's negative 8. Next, we have negative 1. Negative 1 squared, negative 1 times negative 1 is positive 1, and then negative 2 times negative 1 is negative 2. Next, we have 0. 0 squared, which means 0 times 0 is 0, and then anything times 0 is, of course, going to be 0. Next, we have positive 1. 1 squared means 1 times 1, which is 1, and negative 2 times 1 is negative 2. Finally, we have positive 2. 2 squared, 2 times 2 is 4. Notice in every single case, we're doing that exponent first, then we're multiplying. So 2 times 2 is 4. Negative 2 times 4 is negative 8. All right, so let's go ahead and plot these points here. And since they also ask us, describe in one sentence how it's different, we're just going to make the comment that this was narrower. And we'll leave it at that because that was part of what we had to do. All right, so let's go ahead and plot these points here and see how this graph turns out. So negative 2, negative 8, so that would be 2 to the left. And then 8 down because it's negative 8, so not quite to negative 9. Negative 1, negative 2, 1 to the left, and then 2 down, so not quite to negative 3. 0, 0 is the origin. 1 and negative 2 is 1 to the right, and then 2 down, so almost to negative 3. About right there. And then 2, negative 8 would be 2 to the right, and then 8 down, almost down to negative 9. Between negative 9, negative 6, closer to negative 9. All right, so let's go ahead and connect the dots here. And notice, as compared to the parent function, once again, it's narrower. Imagine if this was flipped up, it would be in the same position as the blue one here, the g of x, and this is h of x. We should label that. And so it's not only narrower, but it's also reflected or flipped over the x-axis. So narrower and reflected over the x-axis, or flipped over the x-axis. All right, so that's our example for number 2. All right, finally for number 3, let's take a look at our example for that. Make sure we can see that, okay. And that one we'll do in red. All right, so here we go. So starting with negative 2. So negative 2 squared, negative 2 times, that's positive 1/2. Negative 2 times negative 2 is, keep writing a negative there. Try that again. Negative 2 times negative 2 is positive 4. And then 1/2 times 4, half of 4 is just 2. So that'll be positive 2. Of course, you can just you can deal with this as fractions. 1 times 4 is 4. 2 times 1 is 2. 4 divided by 2 is 2. You can do it like that as well. Next, we have negative 1. Negative 1 squared. Negative 1 times negative 1 is positive 1. And then 1/2 times 1, anything times 1 is itself. So 1/2 times 1 is just positive 1/2. Next, we have 0. 0 squared. 0 times 0 is 0. And anything times 0, of course, is 0. Next, make sure we can see that okay. I think so. Next, we have positive 1. 1 squared. 1 times 1 is 1. 1/2 times 1 is just 1/2. So that's our next answer. And then finally, positive 2 squared.
2 squared means 2 times 2, which is 4. And then half of 4 is 2. And again, you can multiply that out. 1 times 4 is 4. 2 times 1 is 2. 4 divided by 2 is 2. All right, so let's go ahead and plot these points. We have negative 2 and 2. So let's go ahead and do that. So negative 2 and 2, so it would be 2 to the left, and 2 up, so a little bit below 3. And then negative 1 and 1/2, so 1 to the left, and then just a half up. Now this is 0 to 3 here. A half is going to be just above that x-axis there. Next we have 0 and 0, it will be at the origin. Next is 1 and a half, so that would be 1 to the right, and then again up just a little bit, a half, because remember this is not 1 here, that's 3, so a half is like just a small part of that area between 0 and 3. Finally, 2 and 2 would be 2 to the right, and then 2 up, so that would be just under 3. And try and clean the pen off a little bit there. And let's go ahead and connect our points here. Being very careful to keep this accurate there. And that is our j of x function. All right, so how would we describe the graph of j of x as compared to our parent function f of x? So in all three cases, we're comparing these to the original parent function j of x. Well, in this case, the graph is actually wider than the parent function. And that's a result of this 1/2 here. When the coefficient is more than 1, it's going to be more narrow or narrower. And even if it's negative, because we're looking at the absolute value of that number. But if the coefficient of x squared is between 0 and 1, it's going to make the graph wider. And so how is the graph of 1/2 x squared compared to our parent function? It is wider. All right, so again, pause, rewind. There we am back in the screen. Pause, rewind the videos as needed. Make sure you've got a good understanding of everything we're doing. Just kind of center this and maybe step out of the way to give you a second if you want to pause it. And that's it for this lesson for 19.1 as we begin credit 3. And so again, good luck with the work. I'm sure you're going to do great with it. And until the next video, take care and God bless.